Hello everyone, my name is S.Sathwik Uday Kiran. I am pursuing second year CSCD in BBIT. In this video, I want to introduce about what is probability. So in order to know what is probability, let's see some of the definitions. The first one is the sample space. The first definition is sample space. The sample space is nothing but total number of outcomes of an event. Let's see some example we can understand clearly. Tossing a coin, the outcomes are head and tail. So the sample space for the tossing a coin is head and tail. Next example, rolling a dice, which means the outcomes will be 1, 2, 3, 4, 5, 6. So the sample space is 1, 2, 3, 4, 5, 6. So this is about what is a sample space. Let's move to the next definition. An event T. And suppose event T is nothing but a subset of the sample space. That means for suppose we have sample spaces in this I have provided here E. So E is a subset of S. As you can see by the Venn diagram. With the help of example, I can clarify this. So let's see an example of this. Suppose the event E is said to have occurred if the after the outcome has been observed, outcome lies in E. Which means suppose if there if there are, for rolling a dice we have 6 outcomes. So this is a sample space. In that, getting 2 is an event which is a subset of sample space. This is what is an event. As you can see here, rolling a dice, outcomes 1, 2, 3, 4. Suppose event that an even number is rolled. So 2, 4, 6 are the even numbers for this dice. So 2, 4, 6 are subset of the sample space S, and these are an event. So this is about what is an event. Let's see the next definition. Special events. As you can see here, the special events, the null event or the empty set. The phi is equal for a null element, and empty place is equal for the empty, which means there is no possible number of outcomes, means there is no event that is possible for the given condition. And you can see the next one, the entire event, the sample space S. S is equal to the total the event that contains all outcomes. Then empty when phi never occurs, as you can see, as I said before. The entire event S always occurs. Set operations on events. As you can see here, let A and B be 2 events. Then the union A and B is the event denoted by A union B, and it is defined by A union B. A set of E belongs to A or E belongs to B, which means the elements which belong to A and the elements which belong to B all are combined together with the help of A union B. Thus, let's see this one here. The event A union B occurs if the A occurs or the event and B occurs, which means the total possible events occurred in both A and B is called A union B. Now let's move to the next one, intersection. Let A and B be 2 events. Then the intersection of A and B is the event denoted by A intersection B, defined by, as you can see here, A intersection B is equal to set of E, which where E belongs to A and E belongs to B, which means the element which belongs to both A and B is called intersection. This is about A intersection B. Let's see the next one. As you can see here, the event A intersection B occurs if the event A occurs and the event B occurs. Complement. Let A be any event, then the complement of is denoted by, as you can see here, A bar, that is equal to set of E. E does not belongs to A, which means if there is a possible event A, then the not possible events of A will become A complement. That means if probability, as you can see further, I can explain it clearly. The event A occurs if the event A does not occur, as I mentioned before. In problems, we will recognize that we will working with like union, if you see the word, or intersection and complement. Let's see them one by one. And here the particular definition I want to mention, mutually exclusive. If 2 events are called mutually exclusive, if A intersection B is equal to phi, which means there is no common elements between an event A and an event B, then it is called, these 2 sets are called mutually exclusive. See, some conditions are mentioned here. If 2 events are mutually exclusive, then they have no outcomes in common, they can't occur at the same time, The outcome of the random experiment cannot belong to both A and B. Yeah, these are some basic definitions of what is probability. Now let's see what is probability. As you can see by the definition, probability of an event T. Suppose as there are n samples, as you can see here, S is equal to 0, 1, O1, O2, and 3, and so on, On has a finite number of outcomes. Also, each of the outcomes is equally likely because of symmetry, thus for any event T. Probability is nothing but number of number of possible outcomes by number of sample space. As you can see here, P of E is equal to N of E by N of S, N of E by capital N, that is equal to N of E means number of outcomes in E, and capital N is equal to total number of outcomes. Note the symbol N of A is equal to number of elements in A. So this is the probability. The probability is number of available outcomes by total number of outcomes. Let's see the next one. As you can see here, thus this definition of P of E, that is P of E is equal to N of E by N of S is equal to N of E by N of N is equal to number of outcomes in E by total number of outcomes. Applied only to the special case when the sample space has a finite number of outcomes and each outcome is equiprobable. If this is not a true, more general definition of probability is required. Now see like some of the rules of probability. The additive rule, which means P of A union B is equal to P of A plus P of B, which means as you can see by we can get minus P intersection B. The additive rule follows if the two events are mutually exclusive events, then P intersection B is equal to 0. So we will get P of A union B is equal to P of A plus P of B, or you can say that P of A or B is equal to P of A plus P of B. As I mentioned here, they are mutually exclusive, so P A intersection B is equal to 5. So this is additive rule. As you can see here, if two events A and B are mutually exclusive, then they have no outcomes in common. They don't occur at the same time. The outcome of the random experiment cannot be belong to both A and B. As you can see, I have mentioned same as that. In general, the rule of additive rule is P of A intersection B is equal to P of A plus P of B minus P of A intersection B, or P of A or B is equal to P of A plus P of B minus P of A and B. With the help of logic, we will see this rule. A union B, A, B, and the common elements between A intersection as denoted here. When P of A is added to P of B, the outcome in A intersection B are counted twice. Hence, P of A union B is equal to P of A plus P of B minus P of A intersection B. Let's see an example. Saskatoon and Moncton are two types of cities competing for the World University Games. There are also many others. The organizers are narrowing the competition to the final 5 cities. There is a 20% chance that Saskatoon will be among us the final 5, and there is a 35% chance that Moncton will be among us the final 5, and 8% chance that both Saskatoon and Moncton will be among us the final 5. What is the probability that Saskatoon or Moncton will be among us the final 5? Let's understand this in a clear way. Let's take A be an event that Saskatoon is among the final 5. Let B be an event that Moncton is among the final 5. Given P of A is equal to 25, that is equal to 0.20. P of B is equal to 35%, that is equal to 0.35, and P of A intersection B, which means both reaches the final, that means 8%, so 0.08%. We have to find what is P of A, P of A union B, that is note P of A, we know that P of A union B is equal to P of A plus P of B minus P of A intersection B. As you can see here, P of A is equal to 0.20, P of B is equal to 0.35, and P of A intersection B is equal to 0.47. That is equal to 0.47. So the probability of Saskatoon or Moncton will be among us the final 5 is, as you can see, 0.47. So this is how it be done. And see, let us some of the rules for complements. As you can see here, P of A bar is equal to 1 minus P of A. That means P of the possible outcomes is equal to total minus not possible outcomes, or P of not A is equal to 1 minus P of A. complement, as I said before, the event A occurs if the event A does not occur. Logic, let's see the logical how this works. A bar and A are mutually exclusive, as you can see here. Let S is equal to A union A bar, which means the sample space, which means the possible events of A and the possible not possible events of A belongs to sample space S. Thus we can say that 1 is equal to P of S. That means the total possible outcomes is equal to 1. The probability of a total outcomes is equal to 1. So P of S is equal to P of A plus P of A complement. That means P of A is equal to 1 minus P of A complement, or P of A complement is equal to 1 minus P of A. This is the logic. So these are some basic introduction about what is probability. Later we can discuss about what is conditional probability. In this video, this is about what is the introduction to probability. Yeah, thanks for watching.